Today, I'm here to make you dream of this amazing world. And it's a world where you don't have to use passwords anymore. And you might think that someone that works in an identity and a management access company might be pretty savvy in the world of passwords as we know it today, but I'm not. So I want to tell you today one of the many experiences I've had dealing with passwords before, because sometimes you need them to do something as simple as paying with your credit card. And I want to tell you about this experience. So, oh my God, that light. So a few months ago, I was in this big furniture shop that has these self-checkout thingies where you go and pay it yourself. And, I have my stuff. I'm going to pay over there. And I use my card, and then my card asks for my PIN. And I'm like, I never use my PIN. So I go to the bank's application, and I'm like, okay, let me get my PIN. And in the bank application, I was prompted for my password, which I never use because I always use my face or my fingerprint. So I'm like, what is my password? I didn't remember it. I didn't store it in a password manager. I know I could, but it wasn't stored at that time. I know. So here I am, and I'm sweating. I have like a line of 15 people behind me, and they're like, what are you doing? This is supposed to be fast. And I'm like, yeah, but I'm getting my PIN. I eventually managed to get the PIN, get the password, not without getting that SMS code to my phone to recover everything. But I managed to do it after like 15 minutes or so. And the thing about passwords is that they suck. Anybody, do you agree with that? I personally think they suck, okay? Yeah, we're on the same page on that. That's great. And in the many problems that passwords have is that they rely on your memory. We have to remember our passwords, but we keep forgetting our passwords. And the reality is that they can also be vulnerable and can be accessed by unauthorized people. And no one really wants that. So before we dive in, let me introduce myself, because I just started talking. My name is Carla. I am a software engineer. I've been working in this industry for about 10 years or so. Right now, I'm a senior developer advocate at Auth0 by Okta. Sometimes I make YouTube videos, not so often lately. And you can find me as Carla Stabile almost everywhere on the internet. And that's a QR code if you want to, connect with me or whatever. All right, so I do have a few disclaimers to make. The first one is that I might simplify certain things to try to explain them in an easier way, because there are some fancy terms that we don't really need to know about. And also, whenever you see a QR code, feel free to scan that, because I brought a bunch of resources. All right, so what are we going to talk about today? So the first thing that was going to happen today is that I was going to share my dislike for passwords. I think we started off good with that one. Then we're going to talk about alternatives, and then we're going to talk about these two things called WebAuthn and passkeys. So, going with the alternatives. If we don't use a password, what else is out there? And it could be pretty self-explanatory, like passwordless. But if we look to a more fancy or like a fancier definition of this, passwordless authentication is any form of authentication that doesn't require the user to provide a password at login. And you've probably used this in any form, for example, when you get a magic link to your email so you can log in, or when you get like an SMS, a code through SMS on your phone, and then you can log in. Those two examples are examples of passwordless authentication. I personally think it's better. Passwordless, it's better than using a password. And I have a few reasons to say that. The first one is it improves the user experience. Like I said, you don't need to remember anything extra than an email or your username. And then also you can get, you get your link to your email or a code to an SMS. So you're using something that is already familiar to you, and you don't have to think about that old password that you created like 10 years ago. It's also more secure. Because like I said, passwords can be vulnerable. We often reuse passwords. Don't deny it, I do it too. I reuse my passwords. And then we also sometimes share passwords with other people for like, streaming services and stuff. We also all do that as well. So that makes them vulnerable. In fact, like 90% of credential attacks are due to password abuse like this one. And finally, passwordless reduces the cost of ownership, both in time and emotionally. And let me explain on that one. Who in this room has had to create or like implement an authentication system at some point in their lives? Okay, a lot of you, that's great. If you've done that, you know how stressful it is. Because you're like, okay, I have these passwords, I need to store them, not in plain text, hopefully. So I have to encrypt this. I have to hash it. I have to implement password recovery flows. I have to do all these things. And at least in my case, when I'm finished, I'm always wondering, did I miss anything? Is this secure enough? I'm always left wondering like that. And I know if you have felt this stress, then you're wondering, okay, but like, how does passwordless, it's that mouthful, passwordless work? And before we dive into that, I think we need to talk a little bit about authentication factors. And you probably heard this at some point, but let's just briefly talk about them. There's usually 3 authentication factors: knowledge, possession, and inheritance. Knowledge is proving your identity or proving you are who you say you are using something that you know. A PIN or a password, for example. Possession, it would be proving your identity using something that you have. For example, when you get a code to your device, you have that device with you. And then you have inheritance, and that is proving your identity with something that you are, something that is inherent to you, like your fingerprint, you're using the face recognition feature from your phone, or I think now we have this iris recognition stuff as well. All of that is inheritance. Sorry. And the thing about passwordless, actually with passwords, is that we're only using something that we know, right? So when we talk about passwordless, we're getting rid of the knowledge factor, and we're only staying with the possession factor or the inheritance factor. And I might give you a little bit of a spoiler here. And as I mentioned, when you have something that you know, that's usually less secure. And then you switch to something that you have, and that's an SMS or an email or one of those authenticator apps. And then we have other stuff that we're not going to get into it. But the thing is, when you combine multiple factors like that, and you've probably heard of multi-factor authentication, what you're doing is you're increasing the level of assurance. And the level of assurance tells you how confident you are that this user is who they say they are. So the more factors, obviously, the better. I have to look at my notes at some point, so I'm going to be like, okay. So one of the ways you can increase the level of assurance is by using something called public key cryptography. Chances are that if you use Git or GitHub at some point, you've used a form of public key cryptography with SSH keys. I'm not going to go in depth on this part, but basically, in public key cryptography, you have 2 keys. One is the public key, and one is the private key. The public key is public, and it's available for everyone. And the private key is only available for you. You are the only one who can use that one. And everything that you encrypt with one, you can decrypt with the other one, and vice versa. So I mentioned multiple authentication factors, and I also mentioned public key cryptography. But I think we should also talk about phishing-resistant. And with phishing resistance, what we mean here is that we want that every party involved in the authentication system has to actually prove they are who they say they are. Not only me as a user, but also the system I'm trying to authenticate to. And that is something called proof intent through deliberate action, and it sounds very fancy, but honestly, it's just that in order to authenticate, you have to assert or confirm that you actually want to do it. And with all these things in mind, this is where WebAuthn comes into the play. So WebAuthn is actually short for Web Authentication API. And it's a browser-based API that allows servers to register and authenticate users using public key cryptography instead of a password. This is a W3C recommendation. It's been around before 2021, but it's a standard since 2021. So this is kind of official. And I'm wondering, have you ever heard about WebAuthn before this talk? Okay, a few hands, right? Okay, I'm happy with that. Cool. Looking at my notes again. So yeah, this browser-based API allows you servers to register and authenticate using public key cryptography. And the way you do that is by using a piece of hardware that can look a little bit like this. These are called security keys. I wanted to bring mine to show you, but I didn't. I don't know if you have one. They come in like very different forms. We have YubiKey from YubiCo, Google's Titan, and whatnot. And these are called roaming authenticators. But you can also use another type of authenticator, for example, your phone or your laptop, and that would be called a platform authenticator. Here's where the fun comes. Let's see if I can show you how it looks in real time. We have a backup plan, but let's see if we can do this. So I want to show you how registration and authentication looks like from the user perspective using WebAuthn. I have a demo app here. Where's my mouse? There. That I built using a library from some cool people called Cedar Code. So I'm going to do that. So I have a very plain, I'm a backend developer, so bear with me. So we're going to register, and I'm going to have to be looking at that because I don't have my other screen here. So let's try to register here. What we need is a username. Let's say, I can't use Carla because I use Carla all the time. Carla 123 because I don't remember. And so we're going to click register using WebAuthn. And the browser is asking me, okay, you can do that, but you need to authenticate yourself with some sort of device. I'm going to say, okay, let's do it with my laptop using my Chrome profile. It's asking me to create it, and I'm going to say continue. So now I have to do that interaction or that deliberate proof of intention where I say, yes, I do want to authenticate. I have to touch my Touch ID, and I'm registered. And then later on, if I want to authenticate myself, let me log out slowly. And I use Carla123 to sign in. I'm no longer asked if I want to create a new one because the browser already knows there is something with that username, but I still need to prove that it is me. In fact, if I use any other finger, it's just not going to work, right? I know, I don't want to put my password. No! I'm going to use the right finger now. And we're authenticating. So that worked. I'm happy about that because I had backup videos here and everything. So that's how using WebAuthn looks like. That's the backup video, and this is another backup video. I'm prepared. Okay. But now let's talk about what is going on under the hood. It looks pretty easy, right? It's yeah, I put my finger, I'm logged in. But what is going on under the hood? So the first thing that happens when you want to create a new WebAuthn credential, and that is registering. As a user, I'm going to send my username to the browser, and the browser is going to send that to the server. In the context of WebAuthn, that server is called the relying party. That server is going to create something that we call a challenge. And a challenge is a random value that needs to be cryptographically signed later on. We'll get there. So we send that random value back to the browser, and the browser sends it to the authenticator. In this case, I put like a YubiKey, but it can be also my Mac or the iPhone, you know, any authenticator. And at this point, before anything else happens, the authenticator needs to know that someone is really trying to do this. Because think, for example, someone tries to attack your server, right? And they're making these requests, and they're generating challenges and stuff. If there's no user interaction, nothing's going to happen. I literally have to go, touch it, and then something will happen. So you always need to have that user interaction. Once that user interaction happens, and I confirm that I want to create these credentials, the authenticator creates a public key pair and signs the challenge with those keys. And then it sends back to the browser the signed challenge, the public key, and a private key ID. Note, the private key never leaves the authenticator. That private key is always there. No one has access to it. And so the browser sends that to the server, and we can store that in our database. If you think about it, there's absolutely no sensitive data there. That already makes your server way less attractive for attackers. Like, they're going to be there and be like, what's this random string? You know, it's like, OK. So that's how it works when you register. Later on, when you want to authenticate, again, you send your username to the browser sends that to the relying party, and the relying party is like, OK, I recognize this username, so I'm going to give you this challenge, and I'm going to send the private key ID, because you need to sign this challenge with that same key you created this credential. So we send that to the authenticator, and before we sign or do anything, once again, I have to interact with my device, touch my YubiKey, or put my face like this in my phone, any sort of interaction like that. And then the authenticator is going to take that private key ID and look into its private keys to sign the challenge with that same key pair. So it's going to send back, the authenticator is going to send back the signed challenge along with the public key. And the browser sends that to the relying party. And you're probably wondering, why do we need to send the private key to the authenticator and then back the public key again? And that is because, like I said, we need to prove this user is who they say they are at all stages of the process. So the authenticator did it, and now the relying party is going to take the public key compared to the one that had before, and it had to be the same. So everyone knows at this point, OK, this person is what they say they are. You know, we're good. And so that's how authentication works with WebAuthn, basically. But we're going to get a little bit technical here. I'm sorry about that, but I think it's important that you know what the hell am I talking about. All of this process here, the communication between the authenticator and the browser happens, or the client, happens through a protocol called the client-to authentication protocol. And the communication between the client and the relying party happens through WebAuthn. So that's the point where the API is doing something. If we comprise these two, like this protocol and this API, we're comprising a standard that is called FIDO2. And it is built by the FIDO Alliance, which is, and this I'm going to read because I don't know it. It's an open authentication standard hosted by the FIDO Alliance, which is an open industry association with the mission of having authentication standards to help reduce the world's over-reliance on passwords. So basically, they want to get rid of passwords as well, and they're creating a bunch of standards and ways to get rid of them. So for now, if you want to learn more, you can scan that QR code. If not, I'm happy that you remember that it's something called FIDO2. That's completely fine. All right. So I've talked about WebAuthn. I said it's an API, but you probably want to know how does that look like. And it has mainly two methods, or those are the ones that we actually care about. And those are the create method and the get method. The create method, you call it using navigator.credentials.create, and that's how you create a new WebAuthn credential. In the get method, you call it with navigator.credentials.get, and that's how you authenticate yourself. I'm going to show you some code to see how this looks like. Like I said, this is a browser-based API, meaning it's exposed through JavaScript. So regardless of the technology you're using, at some point you're going to have to make this code in JavaScript. So when you want to create a new credential, like I said, you got to use the, no, I'm shaking too much. You have to use the navigator.credentials.create, and what you're sending there is an object that they call public key, and you're going to send pretty much all the information we were talking about just now. So you're going to send a challenge that if you see it's a random value. It looks like a random string, but it's really like a buffer. We're not going to get into details, but it's very random. And then you have information about the relying party. So in my example, my application was called WebAuthn demo, and the ID was my domain, which in my case was localhost 3000. Then you have to send some information about the user, like an ID. This is also a randomly generated ID, and their username. I left the one from the previous conference, but that's fine. And then you have to, or you can say which type of authenticators you want to use. In this case, we're saying use verification required. So when I was talking about the user interaction, bear in mind that user interaction is not the same as user verification. User interaction means, for example, if I'm using a YubiKey, some of them you can just touch and that's done. But if you're using, for example, your Mac and Touch ID, that has user verification because they're actually checking that it is my actual fingerprint. There's a bunch of other options that you can set in this object, but I think these ones are the most important, so these are the ones that I wanted to show you today. Then later on, when you want to get, same, you have a public key object, you send the challenge, and then you're saying which credentials to allow. So we're saying, yeah, we're going to use the public key. There's this ID. So it's pretty much the same. And the transports, I think, if I recall correctly, these are the type of authenticators that you can use, like USB or NFC and all that stuff. Cool. So I said earlier, passwordless is better than passwords. Now I'm saying that WebAuthn is better than passwords. And the first reason to think that is, well, we use public key cryptography, which we know is more secure than password on its own. It's phishing resistant because, like I said, at every step of the way, we're checking, is this the public key that I use? Is this the private key I use? Is this the user one? At every step, we need to make sure that that's happening. You only store public data in your database, like I said, making it less attractive to attackers. And overall, you get a better user experience. If you saw me doing that, it was like 2 minutes to register and log in, just using a username. It was pretty fast. Oh, and most importantly, no more passwords. That's the most important part. All right, so going back to my agenda, we shared the dislike for passwords multiple times. We talk about alternatives, and we talk about WebAuthn. So now we're heading to the next part of this talk, which is we got rid of the password, right? Like we're living in this world where we're not using passwords anymore. We're only using WebAuthn or whatever. But what if we want to take it to another level and say, what if I don't even have to remember if I have an account created for a service or not? And the browser can already know that for me. You can. And you can use something called passkeys. Passkeys, this is THFest, this is passkeys. Nice to meet you all. Thank you all for being here. And now passkeys are, this is like the marketing, the slogan. Passkeys are the replacement for passwords. And it's fun because we're getting rid of the word. We're adding public keys, so it's passwords, passkeys. And also, a password is something that you know, and a passkey is more of a secret that you need to unlock somehow. So passkeys, they're intuitive because they create an experience that is familiar for end users. They're also secure because they're phishing resistant, and I'm going to tell you why in just a minute. Well, they rely on public key cryptography, but we'll get to that in a second. They're non-reusable. There's no way you can reuse a passkey in contrast to a password where you can just copy and paste it everywhere. And they're just convenient. They allow you to just access with just existing. I exist, and then I can have a passkey. If we get technical, a passkey is a FIDO2 discoverable credential. And if you remember that diagram I showed you earlier, and I was like, I'm just happy if you remember FIDO2. FIDO2 is a set of standards that is composed by WebAuthn and CTAP2, the client-to authenticator protocol, which means that passkeys are using WebAuthn under the hood. So with WebAuthn, we're communicating with the relying party. And then we also have this discoverable credentials part, because that's the part we haven't really talked about. A discoverable credential is basically a way that your server or the relying party has to already know or to discover that that account has already been created or that username already exists and can show it to you. Something important to keep in mind is that WebAuthn credential, a WebAuthn credential, is not considered a passkey unless it's discoverable. We'll get to that in a second. I know, I'm looking at your faces. And you're probably wondering, okay, if we're moving forward to this discoverable thingy, why would we even care to use what I just showed you if now we can use this new thing? And honestly, the main reason is backwards compatibility. So as of today, there's still a lot of authenticators that don't have this discoverability thingy. And so we need to still be able to use them. Also bear in mind that passkeys are extremely new. Like, I think the term got famous probably in 2022 by Apple in that big Apple event that they do. I don't remember the name. So we're talking about, like, I'm doing this talk today, but if I do this again in like a month, I might have to change some stuff because it's still evolving and it's still changing. In fact, this discoverable part wasn't like this until like 5 months ago. So we're still evolving, we're still adopting it. As of today, we have two types of passkeys. We have sync passkeys, and those are the passkeys that you can sync to a cloud-based service, and it's available in multiple devices. For example, when I was doing the demo and I was asked to, do you want to use your Chrome profile? If I store that in my Chrome profile, that is it would be a sync passkey. Or if I store it in my iCloud, it would also be a sync passkey because I'm syncing that to the cloud. And then we have device-bound passkeys, which are, you can only store them in a single device. For example, if you use a YubiKey, one of the ones that I showed in there, that it's only going to be in there. It's super secure. In fact, device-bound passkeys are considered to be more secure than sync passkeys because in order to have it synced on the cloud, the private key has to actually be synced into the cloud. Whilst with the YubiKey, you only have it with you in your pocket or whatever you have it. Fun time. Let's show you how passkeys look like in action. Can you see it? Okay. Have it here. All right. So I have here a login form. There's not much to it. I have an email address. And then I have a button that says continue with the passkey. But I'm going to register first, so I'm going to go to sign up. Do you believe me if I tell you that I tried this like 5 minutes ago and it worked? Honestly, my life. Hello. Do we have Wi-Fi? Because that might be it. Yeah, we do. Okay. Bear with me. You were not supposed to see this, but it's okay. That's what happens when I try to be brave and try to do a live demo. Okay, are you gonna work now, or are you just gonna be like mean to me? Okay, thank you. Now it's working. So I'm gonna create an account, just a random account. I'm gonna say, Carla at test.com. And then I'm gonna click continue. This is asking me, it's telling me all the benefits of passkeys, which I already know. I swear to God, you saw me doing this. Okay, I'm not crazy. You know what, that's fine, because I have a video, because I knew this could happen. Where's my mouse? Do you see it? Life is like this. Okay. Well, it didn't work. I have a video. It's okay. So, to create a passkey, if you please, thank you. I'm going to click on create passkey. I really wanted to do this live, so I just put a random email there. I think it was Carla at test.com. That's my go-to email using my own name. And you see the flow is very similar to WebAuthn. Yes, I get the same thing, asking me, telling me all the good things about passkeys. And then I'm prompted to decide where to store my passkey. I said my Chrome profile again, click. And then I'm going to click continue. At that point, I have to interact with my device or with my authenticator. And there it works, because I pre-recorded it. So that's great. Later on, when you want to authenticate, we'll just directly use the continue with passkey button, because we already know we have that. Or, this is where I realize, oh wait, but if I delete this and then I click on it again, I'm going to delete it. The browser is suggesting the passkeys that are already created for that domain, which in this case was passkey something something. I have to interact again, and then I can log in. So the difference here, the difference between what you saw here versus what you saw with WebAuthn was that ability for the browser to suggest the passkeys that I have created for that site. That's like we can call it the visual difference. There's a lot more going on under the hood, but visually speaking, that's what we see. Like I said, I want to keep it real for you, because we still have some challenges with passkeys. Like I said, this is still very new, and right now, passkeys have operative system or browser support. So I don't want to say vendors, but we depend on operative systems and browsers to implement the passkey spec. So the support might not be uniform. And what we mean by this is that if you use passkeys with Google, you might have one experience. If you use passkeys with Apple, you might have a different experience. In the end, they're all using the same technology and the same standards and stuff under the hood, but because there's no other guidance, everyone's doing, whatever. Also, we have cloud vendor reliance, and that means for sync passkeys, we're still depending on companies like Apple and Google and Microsoft to save the private keys on their cloud. And for some people, that's not okay, so we still have that reliance, and that can probably slow down adoption a little bit, but we're hopeful that it's going to improve. Then for big companies, we could have some situations where they might want to have more control about what they do. For example, what if you work for a company and they decide, no, we're not going to enable iCloud for you? Then you can't use sync passkeys anymore in that case. And then for reset and recovery flows are still a work in progress. So there's no like a standard way of doing it yet. All right, so back to my little agenda. I think we covered it all. We shared my dislike for passwords, the alternatives, WebAuthn. The passkeys demo didn't work, but I got a video, so that's cool. And that's pretty much what I wanted to talk today. But to wrap it up, I want to tell you where passkeys are available today. Obviously, Google, Apple, Microsoft, Auth0 as well. But also, if you use GitHub, you can create your passkeys on GitHub. That's actually pretty cool. I did it not long ago. I've also heard that Kayak has a very nice passkeys experience, call it like that. And of course, 1Password. There's many, many more, and it's still growing. So yeah. If you want to learn more about passkeys and WebAuthn, you can go ahead and go to these resources. We have webauthn.me, and in this side, you can do the whole flow that I did where I go from the user to the browser to the relying party. You can do that, and it's like more interactive than what I just showed. And then we also have a passkeys playground, learnpasskeys.io, where you can go ahead and test it out and see what's going on every step of the way, what's the exchange of data at every point. I think it's very interesting. I highly recommend that you check that out. And the last one I think is passkeys.dev. This site is actually hosted or owned by the FIDO Alliance, which are the, they're the ones saying how we should do things in this matter. So that's a good website as well. And then finally, I don't know if you noticed, but I'm wearing, you probably didn't because it's upside down. I'm wearing this badger thingy. It says my name and whatnot, and it's a P. Moroni Badger 2040W. And I would really, 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 I need to ask you first something. So I would love to have some feedback on this talk, how you feel about passwords, how you feel about passkeys. And I brought a few of these, so my plan was to give them away randomly from the list of people there. I will not use your emails for anything else. I really don't need them. So I just really need feedback, really, to improve and also to understand, like, what's your take on passkeys? Do you like it? Do you hate them? I just want to understand. So feel free to scan that QR code or go to a0.to/techfestform. And yeah, if you leave me your email, I might write you to let you know that you got one of these. I'm going to just wait until you scan that one because that's the most important one. I'm upset about that demo. I see phones still out, so that's great. Done? Cool. All right. So this was a ride. I'm sweating. I'm very nervous. But, I mean, it was a fun ride. But most importantly, it was a ride without dealing with passwords. We deal with, network issues, but that's just life. So thank you so much for being here. And I hope you enjoy the rest of the conference. Thank you.
Hello. We have time for 2 questions. Does someone have a question?
Just a quick question about the WebAuthn you talked at the first of the lecture. You told that the private key was stored on the original device you did the signing. So what about if you want to log in other devices?
Yes, you can do it, and I wanted to show you in my demo. So basically, with passkeys, and those sync passkeys, the cool thing about them is that you can use them in multiple devices. So for example, if my demo would have worked, I could have shown you that instead of selecting, for example, using my Chrome profile, I could have, I think the option is called sign in using another device. When you click on that, you get a QR code. So what you do is you grab your phone, for example, scan that QR code, and then at least on iPhone, it tells you like log in with a passkey. You click there, and then you follow the passkeys flow, like the user interaction, face recognition from your phone, and then it syncs automatically to your browser. I wanted to show you that. I really wanted to. In fact, I'm gonna post this on Twitter because I'm like upset. I'm gonna post it. I'm gonna show you. So yeah, you can do it from another device. And there was something else I wanted to say about that. I think that was it. Yeah. Also, depending on the implementation, but at least the one from Auth0 is that you can only scan that QR code if you are within range in Bluetooth. Like, if I put that QR code there and someone in like very far away destination tries to do it, it won't work. It will work to me that I'm close to the other device. Hopefully that answers the question.
Okay, so only one more.
You can also ask me in Spanish if you want. I was just preparing this in English.
Okay. Well, hello. Thank you for your speech. I wanted to ask you about Web3 authentication. Did you have any experience with it?
No.
Okay.
Web3 authentication? No, but I should though. I mean, there's a bunch of things about Web3, like verifiable credentials and all of that. I know a little bit about it, but I haven't worked directly with it. I would like to though. There's some questions here. They're struggling because we're late.
No, sorry, we don't have more time.
Okay, you can find me. I will be here. You can, well, I won't be here because I have to leave too, but I will be at the Okta stand downstairs probably. Thank you so much, and I hope you liked it.